All right, so in this video, we solved the partial differential equation 3u partial of u with respect x equals to 4 partial of u with respect y, subject to the condition u of x 0 equals to 2x plus 7. So to solve this equation, we're going to assume a solution of the form u of x y. Notice in this case, we don't have a function of t, we have a function of x and a function of y, right? And that equals the product between a function of x and a function of y. All right, so we're going to take the necessary derivatives as required by the PDE. That is the partial of u with respect x, which is f prime, g remains constant, and then the partial of u with respect y, which is f, which remains constant, and g, which becomes g prime. Okay, so substituting this into the PDE, okay, so 3u, that's gonna leave us with 3 times u, which is really the product between f and g, times partial of u with respect x, which is f prime g. And that equals 4 times the partial of u with respect to y, which is f g prime. All right, well, let me simplify this equation a little bit. So number one, this is going to be 3f f prime g squared equals to 4fg, and dividing both sides by fg, which is what we have been doing, if g prime fg, that's going to leave us with, okay, leaves us with 3, the f's cancel out, f prime g squared over g, that's going to leave us with a factor of g equals to f's cancel out 4 times g prime over g, right? And we're almost there to separating the PDE, right? Except that we need to make a couple of arrangements. And number one, I would like to have the g function, the g part of the solution. Um, this I'm going to have all move all constants to that side. Also, it seems like there is a factor of g that needs to be moved to the right hand side of the PDE. So dividing both sides by 3g, that's going to leave us with f prime equals to 4 thirds, or 4g prime, divided by 3g times g, that's g squared. And well, at this point, we have the equation separated, and let that be equal to k. All right? So, f prime equals to k. That's to get the solution for the f equation. And see how simple this equation is. So simply change the f prime to a df dx, which equals to k. So f, rather df, equals to k dx. And at this point, let's integrate both sides. All right, so integrating, we get the integral of the f, that equals to f, and the integral of k is kx, however, plus some constant of integration. All right? Okay, so that is the solution for the function f. Right, let me continue up here to solve the equation for g. And I'm going to need all of this space right here. So I'm going to continue. So 4g prime over 3g squared equals to k. Right, so in this case, well, this is what I'm going to do. I'm going to move all the constants to the right-hand side of the equation by multiplying both sides by 3/4. So that's going to leave us, number one, with 1 over g squared times dg dy equals to 3/4 k, right? Keep separating the variables because g here is a dependent variable and it's a function that depends on y. So we're going to be left with dg over g squared equals to 3 over 4 k dy. All right, and we're almost there. We're almost there to integrate. However, to integrate the left hand side, we will need to move this g squared to the numerator with negative exponent. Let that be equal to 3/4 k integral of dy. So this will be simply 3/4 k y plus some constant, but again, we're going to use a different letter, not c, we're going to use d. And then the integral of g to the negative 2, that's going to leave us with negative g to the negative 1. All right, in this case, we're not getting a natural log like we were getting in other PDE. So this time we got something else. So, okay, let me clear the negative exponent. That's going to leave us with negative 1 over g, okay, equals to 3 over 4 ky plus d. And, well, I'm going to multiply both sides by negative 1 to get 1 over g equals to negative 3 over 4 ky plus d. So I'm going to distribute the negative sign. So distributing the negative over the first term is going to leave us with negative 3/4 ky. However, that negative multiplied with the constant of integration d is just going to be by, the negative is just going to get absorbed by the constant. So that's going to leave us with d minus 3 over 4 ky, and we're almost there to get the g. So you might want to consider the right hand side. Think of the right hand side of the equation as d minus 3/4 ky over 1 and simply flip both sides of the equation. So that'll be g equals to 1 over d minus 3 over 4 ky. All right. So what we're going to do next. So now that we have the solution to, essentially the solution to the PDE, well, that's actually the two functions that will comprise the general solution to the PDE. So that is the product f of x, g of y, for which we have kx plus c times 1 over d minus 3/4 ky. All right. Okay, so let's just simplify this. Let's clean this up. And in this case, well, there will be no absorption of constants of integration like we did in other exercises where the product just absorbs into one single constant of integration. In this case, it's going to look like kx plus c and everything divided by d minus 3 over 4 ky. And well, I know what you might be thinking. Maybe multiplying numerator and denominator by 4 so we can clear the complex fractions. Yes, however, I think I'd rather do that once we are done, once we get the particular solution. So let's leave it like this for now. So at this point, let's go ahead and use the initial condition. That is, u of x0 equals to 2x plus 7. So with u of x0 equals to 2x plus 7. That means we're going to evaluate u of x0 in the general solution, that is not t, y. Yes, not t, y. Um, Evaluate or replace y with 0. So that is u of x0 equals to kx plus c divided by d minus 3/4 k times 0. So that whole term in the denominator is going to be equal to 0. So that's why I didn't want to multiply by 4 to simplify the complex fraction. Okay, so it's going to leave us with kx plus c divided by d. And u of x0, what is that equal to? 2x plus 7. Okay? Now, the question here is how are we going to equate coefficients? Well, here, for this to be an equation, check this out. Number one, the coefficient of x, which in this case is k, equals the coefficient of x on the right-hand side of the equation. And then the constant term c equals the constant 7 on the right-hand side. But what about d? Well, for d, you might want to think of the left-hand side of the equation as divided by 1. There's an invisible 1, right? And from here, why not? Let me actually change color. I like this color. So I'm going to highlight. It's not going to look well. So this is different highlighter. It is d equals to 1. All right. Okay. So with this, we can write down our coefficients. Okay. K. Oops. K equal to 2. C equals to 7, and D equals to 1. All right, so we may go ahead and write the particular solution. Finally, u of x, y, this time not t, equals to k, which is 2, x plus c, which is 7, and then divide everything by d, which happens to be a 1, minus 3 fourths k, oh no, 3 fourths y, simply y. All right. And at this point, that's where I'm going to multiply numerator and denominator by 4, right? Oh, this is k, which is 2, y. No, so we're going to keep simplifying this. 2x plus 7, 1 minus 3 halves y, and at this point, multiply numerator by 2 and divide by 2 to clear the complex fractions. So that's going to leave us with u of x y equals to 4x plus 7, times 2, which is 14, because we're distributing the 2, and that is 2 times 1, which is 2, minus 3y, right? And that is final answer for the particular solution.